I'd like to thank ChemAxon for the opportunity to present Glysade's recent work toward integrating ChemAxon toolkits into Spotfire. This presentation promises to be of interest to companies that use Spotfire for data analytics and ChemAxon for Cheminformatics. A bit of background is in order to explain how the integration work was done and how ChemAxon toolkits can be used in Spotfire. Glysade writes an extension for Spotfire called Lead Discovery ChemCharts. ChemCharts is available through Glysade's sales partner, PerkinElmer. ChemCharts provides visuals and functionality that support research and development in biologics and small molecule drug discovery. I've included screenshots of some ChemCharts visuals on this slide. Here's an interactive 3D viewer, a table plot capable of displaying both small molecules and sequences, and here's a multiple sequence alignment viewer that also is able to show annotations and distribution plots of data associated with those sequences. A lot of time and thought has been put into the design of visuals that are used in support of small molecule drug discovery. In this table plot shown here, it can toggle between a standard vertical view and the transposed view that has the data arranged horizontally. Here's an example of a SAR map visual showing the results of a multi-core decomposition. In fact, most of the work in ChemCharts up to this point has been on advanced visualization. Lately, however, we've been spending more effort on analytics than visualization. In the latest release of ChemCharts, Glysade added the chemistry visual shown here on the right. The chemistry visual provides centralized access to Cheminformatics tools. It also allows for configuration of Cheminformatics behaviors in a Spotfire document. The chemistry visual in this screen capture is showing a substructure and a similarity search. These search controls provide a summary of the type of search that was performed and the parameters used in the search. Substructures on other ChemCharts visuals may be highlighted and aligned using search controls. Data can be filtered using the corresponding filter controls at the bottom of the search controls. Now, the keen eye will recognize all of the depictions on this page, both in the table plot and the chemistry visual, have been generated with ChemAxon toolkits. In fact, the substructure and similarity searches were performed by ChemAxon toolkits wrapped inside of Spotfire data functions. While the Cheminformatics represented on this slide are fairly basic, they demonstrate an important point, that the integration work is intended to address both the basic and advanced features of Cheminformatics toolkits in a Spotfire context. As a brief aside, aesthetics and ease of use are priorities in ChemCharts. The structure searches shown in the previous slide were added by right-clicking over a structure in a ChemCharts table plot to open the context menu. Users can choose to add a substructure or similarity search. Although not shown here, Marvin.js is supported for editing queries. The structure search controls on the previous slide were minimized using toggles at the tops of the controls to produce a simplified view. The visual is reactive to the amount of real estate configured for the visual. Structure searches will automatically be arranged either vertically or horizontally depending on the bounds of the visual. So that's a quick overview of the structure search features of the chemistry visual. I'd also like to point out the calculators and settings represented by icons at the bottom of the visual. Let's take a closer look at the calculators. Property calculations were a primary driver for the integration of ChemAxon toolkits in Spotfire. ChemAxon toolkits have a plethora of property calculations that are useful when working with small molecules. Adding calculations through the chemistry visual is a breeze. Here you can select the property calculations from the calculators section of the chemistry visual. That opens a list of available properties that can be calculated. There are more than 80 property calculations that can be added to an existing data table using the ChemAxon toolkits. Fortunately, user-defined lists of property calculations are supported in the chemistry visual. One simply needs to select the predefined list of properties from the short lists drop-down and click the Add Shortlist Properties to the selection widget and click OK. Because the property calculations are wrapped in a Spotfire data function, every time new data is loaded into a data table, the property calculations are automatically updated. Property shortlists are configured in the Settings section of the chemistry visual. And while I won't go through the process of defining property lists in the interest of time, it is worthwhile to touch on a different part of the settings, namely toolkit configuration. This is the settings dialog in the chemistry visual. ChemCharts was designed to support multiple Cheminformatics toolkits. While Glysade has provided a default RDKit implementation of Cheminformatics features, it was important to support customer preferences. For features like property calculation, ChemAxon has far more to offer than RDKit. Users may have strong opinions on structure depiction. It may be desirable to have the results of substructure and similarity searches agree with other tools within an organization. So we've given users control over Cheminformatics toolkit preferences through the chemistry visual settings. Now let's move on to advanced Cheminformatics features in Spotfire with a demo of the neighbor properties visual. The neighbor properties visual was designed to explore relationships between chemical structures. It can be used to validate hits in HTS datasets. It can also be used to understand activity cliffs and SAR around active compounds. When the visual is opened, the nearest neighbors for each compound in a dataset are calculated automatically. In this case, neighbors were calculated using ChemAxon ECFP fingerprints. The landing page displays representative compounds from the dataset that pass the filter settings in the panel on the right-hand side. This is a set of compounds taken from ChemVisual that have associated activities, and I've already filtered on activity. Note that the border colors are all green, indicating that these are highly active compounds. The controls on the landing page work just like a map chart. I can also click and drag to move all the compounds or just a single compound. A nice side effect of the SVG images produced by the ChemAxon toolkit is that they're transparent, so I can superimpose images just by clicking and dragging. Now I'm going to filter on the neighbor transition counts as I would do when exploring activity cliffs. Neighbor transition counts are calculated automatically when the neighbor properties visual is opened. Transitions are defined as neighboring compounds that are categorized in the opposing activity or property class. Since I'm looking at activities, a transition would either be active to inactive or vice versa. Activity cliffs must, by definition, have at least one transition. Based on the filter settings I've chosen, this compound has multiple transitions. I can see its near neighbors just by clicking on it. The blue arrows indicate transitions. The burnt orange borders indicate inactive compounds. I can rearrange structures just by clicking and dragging. And I can zoom in using the mouse wheel. Structures 975 and 977, the chlorothiazole has been replaced by reasonable alternatives. both of which were inactive. The ability to explore local chemistry space can aid understanding of structure-activity relationships. Of course, it would be possible to do the exploration of the structure-activity relationships from a table plot, but the neighbor properties visual makes it much easier. The steps to validate actives in an HTS dataset would be slightly different. In an HTS dataset, we would typically look for active compounds that have active neighbors. Active compounds that are not promiscuous binders and have active neighbors are likely to be verifiable hits. A combination of filtering on activity and the upper neighbor counts column could be used to identify hits that have active neighbors. The upper neighbor counts column, computed automatically when the visual is opened, contains the number of neighbors in the same activity class. If enough neighbors are found to establish a neighborhood, one might hope for structure-activity relationships to come directly out of the HTS hits. The definitions of active, inactive, or any other desirable property depends on the experimental data in the data table and the user's definition of the activity or property classes. I'd like to wrap up the presentation by talking briefly about future directions. The initial release of the ChemAxon package for Spotfire and ChemCharts is expected shortly. It needs more testing and validation before public consumption. After the initial release, we'll begin work on moving some of the features implemented with .NET wrappers to microservices and Pipeline Pilot. Some of the features currently in the package have been implemented with .NET versions of the ChemAxon toolkits for the sake of expediency. Features like depiction and substructure search will continue to be called through .NET wrappers as performance is paramount. Property calculations in less performance critical parts of the code will be moved elsewhere. I think that supporting both microservices and Pipeline Pilot will be important, but I'd appreciate feedback on that topic from the audience. Finally, I'm excited about where this project can go. ChemAxon toolkits have a plethora of functions that I can see being useful for small molecule drug development. Metabolism prediction and Marcouche enumeration are high on my list for the next phase of integration work. If there are features that members of the audience would like to see integrated into Spotfire, I would be interested in hearing their opinions as well. In conclusion, I'd like to thank my colleagues Paul Watson and Gareth Jones for their outstanding contributions to the work. I'd like to thank the good folks at ChemAxon for assistance in the development process. Brock Ludy and Carol Pressig were instrumental in getting the project off the ground. Finally, I'd like to thank the audience for their time and attention. Questions beyond the Q&A session may be directed to business@glysade.com. Thank you.